Hello and welcome to today's lecture. So today we're going to start chapter 5. So chapter 5 is about normal distribution. What we learned so far? In previous chapter we learned about a random variable. And we said that, hey, a random variable can be discrete or it can be continuous. Very well. So when it comes to a discrete random variable, we talked about discrete probability distribution. Discrete probability distribution. Well, for a continuous random variable, we have continuous probability distribution. So continuous probability distribution. One of the important continuous probability distributions is called a normal distribution. So very well, today we're going to talk about a normal distribution. So these are the objectives. A normal distribution. Well, we're going to talk about z value. So standard normal distribution. Using z-table and calculator to actually calculate the area below the graph. Use z-table and calculator to find the area below the graph. These are our objectives for today's lecture. Let us take a look at our node and go over the properties of a normal distribution. So, a normal distribution is a continuous probability distribution for a random variable like x. The graph of a normal distribution is called normal curve. Normal curve. So we have the following properties for a normal distribution. First of all, the mean, median, and mode are all equal to each other. Mean, mode, median, they are all equal to each other on the horizontal axis. 2, the normal curve is bell-shaped and it's symmetric about the mean. It means that if I just flip this, I get the exact same area on the left and on the right. 3, the total area under the normal curve is equal to 1 or 100%. 4, the normal curve approaches, it's getting closer and closer, but never touches the x or horizontal axis. And it extends farther and farther away from the mean. So these two are going to the left, to the right. 5, between mean minus standard deviation and mean plus standard deviation, the graph curves downward. So take a look at this. Between these two, the graph curves downward. The graph curves upward to the left of mu minus standard deviation, and to the right of mu plus standard deviation. Graph opens up. The points at which the curve changes from curving upward to curving downward, curving upward to curving downward, curving upward to curving downward are called inflection points. Very well. We have learned that a discrete probability distribution can be graphed using a histogram. For a continuous probability distribution, you can use a probability density function. A probability density function has two requirements. First of all, the total area under the curve is equal to 1, and second of all, the function can never be negative. A normal curve with mean mu and standard deviation sigma can be graphed using the normal probability density function given below. So function y is equal to 1 divided by sigma standard deviation times square root of 2 pi e raised to x negative x minus mu squared divided by 2 sigma squared. Remember that e, or Napier number, approximately 2.718, and pi approximately is 3.14. Let us take a look at one example. Example says, which normal curve has a greater mean? Which normal curve has a greater standard deviation? Very well. Take a look at your curve B. For curve B, the mean is equal to 12. So mean of curve B is equal to 12. And mean of curve A is actually equals to 15. As you can see, 15 is greater than 12. How about the standard deviation? Which graph is more varied? As you can see, your graph B is more varied than graph A. So, standard deviation of A is less than the standard deviation of B. So very well, we introduced a normal distribution. And our normal distribution depends on x values. So here you have your x values, and then you have your normal graph. Okay, so in the middle you have your mean plus 1 standard deviation, mean plus 2 standard deviation, and mean plus 3 standard deviation. On the left-hand side of the mean, we do the subtraction. Mean minus 1 standard deviation, mean minus 2 standard deviation, and mean minus 3 standard deviation. Very well, I'm simply to ask, how can I convert this normal distribution into a standard normal distribution where I can actually use my z values? How we can standardize this distribution? We can use z, formula that we learned before, equals to x. We can take each x value minus mean of the data divided by standard deviation. So let's see what changes we have here. We're converting a normal distribution into standard normal distribution. Very well. So here I have my new horizontal axis, and here I'm having Z values. And okay, I'm going to get the exact same normal distribution. The shape is the same. Of course, on horizontal axis, I get different values. So take a look at this. I'm going to take mu, the mean, and I'm going to just substitute the mean for x, because one of my x values is the mean. So z is equals to x minus mu divided by sigma. I'm going to take this mean, I'm going to punch that into z. So my z is equal to, my x is mean, so here I have mean minus mean divided by sigma, 0 over sigma, which is 0. So my center was mu, now the new center is equal to be 0. This is your 0. Very well. Let's take a look at another number here. Mu plus 1 standard deviation. So I'm taking mu plus 1 standard deviation. I'm going to punch that in here. I have z equals to mu plus 1 standard deviation minus the mean, mu divided by standard deviation. Very well. Mu minus mu is equal to 0. You get sigma divided by sigma, which is equal to 1. So my next number, which was mu plus 1 standard deviation, is now just 1. My next value is going to be 1. This is just 1. Okay. What's your guess for mu plus 2 standard deviations? If I plug in mu plus 2 standard deviation into z formula, I have mu plus 2 standard deviation minus mu divided by standard deviation, which is actually, I can cancel out mu and mu, I get 2 sigma divided by sigma, which is 2. So my next number on the horizontal axis is 2. Here, just write 2. Also, what's your guess for the next value? It's going to be 3. There you go. What about the left-hand side of 0? On the left-hand side of 0, if you plug in mu minus standard deviation, you get negative. Then negative 2, and finally negative 3. So instead of working with x values, we can just work with z values. Remember that when we have z values, we can use a z table to calculate the area or probability. So we have a standard normal distribution. And the area is equal to 100% or 1. So let us go over some examples and actually use our z table, then use our calculator to use our z values and find the area. There you go. When you're using a z table actually gives you the area to the left-hand side of the z value. So note that. A z table provides the area to the left side of z. What do I mean by that? So suppose you have a standard normal distribution, and this is the graph that you have. Well, suppose your Z is here. This is your Z. The area to the left-hand side of Z area to the right-hand side of Z. Very well. So if the question says, find the area or probability that your Z is less than a value, the given value, when you're using your Z table actually gives you the area to the left side. It doesn't give you the area to the right side. So step by step, we're going to learn how to read our Z table. Let's take Very well, let's take a look at our notes. On page 3, you have the following example. Example says, find the cumulative area that corresponds to a z-score of 1.15. 1.15. So first of all, you have a decimal number, 1.1 plus 0.05. You need to find 1.1 on the first column of the table, and you need to find 0.05 and 0.05. You need to find this decimal number on the first row of the table. Then you're going to find the intersection between them. What do I mean by that? So this is your Z table. It has negative numbers and it also has positive numbers. The number Z is 1.15. So 1.1 plus 0.05 on the first column, on the first row. On the first column, we have to find 1.1 corresponds to 1.1. And on the first row, we need to find 0.05 and find the intersection between these two, and it gives you 0.8749. So the cumulative area to the left-hand side of 1.15 is 0.8749. Cumulative area to the left. How about the second one? Find the cumulative area that corresponds to z-score of negative 0.24. So you have negative 0.2 and 0.04. If you add these two negative numbers, it actually gives you negative 0.24. Let's take a look at our table. Our Z is negative. Take a look at your Z, negative 0.24. So we have to take a look at negative z-scores. 0.2, negative 0.2, and 0.04. The intersection between these two gives you the cumulative area to the left side, which is 0.4052. Now let us use our calculator to actually see the result of the calculator. To use your calculator to find the cumulative area to the left, turn on the calculator. Second, vars. You need to go to normal CDF. Normal CDF. Since it's to the left-hand side, your lower limit is going to be -1 E99. It means that you have a very small number on the left-hand side of your graph. Your upper limit is going to be, for the first one, 1.50. 1.50. Since you are working with z-scores, it means that the mean is 0, standard deviation is equal to 1, so enter and get the probability or the area to the left-hand side, cumulative area to the left-hand side of z equals to 1.50. As you can see, we have the exact same cumulative area to the left. How about the second one? Your z-score is -0.24. Second, vars, normal CDF, enter. Again, since the area is on the left-hand side, your lower limit stays the same, -1 E99, and your upper limit is going to be -0.24. So to enter negative sign, -0.24. Sigma is 0, mean is 1, and let us do the calculation. We get 0.40516. So if you round this, you get 0.4052, the exact same cumulative area to the left-hand side of the graph. So on page 3 of the note, if the question says find the cumulative area to the left of a value, like z equals to a number like a, you either use your z table or you use your calculator. For your calculator, we have to follow the following steps. Second, vars, normal CDF. Now that you have your normal CDF and you're looking for the cumulative area to the left, your lower limit is -1 E99, a very small number to the left-hand side. And upper limit is going to be z, which is equal to a. Remember that your mean must be equal to 0 and standard deviation must be equal to 1. It gives you the area, cumulative area to the left-hand side of this number, this z, which is equal to . expect you to ask, what if the question says, find the cumulative area to the right-hand side or in between? What should we do? So if the question says, find the cumulative area to the right of, suppose your z is equal to b, then to use your calculator, you're going to go to second, vars, then find normal CDF. After finding the normal CDF, your lower limit is now b, and your upper limit is equal to positive 1, E99. Since you're working with z, don't forget that your mean must be equal to 0 and standard deviation must be equal to 1. So we're finding the cumulative area to the right-hand side of this is your z. All of the z values are on horizontal axis. And suppose you have your b here. And the question is asking to find the cumulative area to the right side of b. The right side, it's going to be here. And finally, what if the question says, in between, find the cumulative area in between A and B. Remember that we are working with z values. Then you can use your calculator. The same process. Second, vars, normal CDF. After that, as you guess, your lower limit is going to be A. Suppose A is less than B. And your upper limit is B. Mu is 0 and sigma is equal to 1. Then you're done. You find the cumulative area between A and B. Okay, suppose your A is here. Suppose your B is here. The cumulative area between A and Z. Let us take a look at some examples. So suppose question says, find the cumulative area on the left side of 1.23. 1.23. Let's turn on the calculator. Second, vars, normal CDF. Your lower limit, since it's on the left-hand side, your lower limit is going to be -1, E99. Your upper limit, it stops at 1.23. Mu is 0, standard deviation is 1, and enter. The area is equal to 0.89. 0, if you round this, you get 7. So as you can see, by using a table or using a calculator, you get the exact same value. What if the question says, find the cumulative area on the right side of 1.23? Well, to use your calculator, second, vars, normal CDF. Now your lower limit is 1.23. So 1.23. Your upper limit, it goes to the right-hand side. So this number cannot be negative. It's a positive number, which is 1 second EE and 99. Enter. You get the area, which is equal to 0.1093. And finally, when we are finding the area in between two values, the lower limit is negative 0.75 and the upper limit is 1.23. So second, VARS, normal CDF, your lower limit is negative 0.75, so negative 0.75. Your upper limit is 1.23. And then the mean is 0, the standard deviation is 1, and we're going to enter another. And the area, cumulative area between these two numbers is actually 0.6640. This is the area. More examples. On page 5, question says find the area under the standard normal curve to the right of z equals to 1.06. 1.06. You get a positive number and it's on the right-hand side. On the right-hand side. So if you look at the graph, if you look at your graph, on the right-hand side of the graph, so remember that this is 0, 1, 2, 3, minus 1, minus 2, minus 3, 1.06, so roughly here, roughly here. Area to the right, area to the right. So let us use our calculator. Here we have second, VARS, normal CDF. Your lower limit is 1.06. Your upper limit is going to be a number on the right-hand side, which is 1 second EE 99. Mean is 0, standard deviation is 1, and enter. The area is 0.1446. 14.46%. For the second example, it says, find the area under the standard normal curve between a negative and positive z values. So take a look at the graph. Here we have the normal distribution, 0, 1, 2, 3, minus 1, minus 2, minus 3, negative 1.5. Negative 1.5 is here. Positive 1.25, 1.25 is here. So we're looking for this area, this area. So second, VARS, normal CDF, negative 1.5, negative 1.5, and here you have 1.25, mean is 0, standard deviation is 1, and let us do the calculation. We get 0.8275. This is the area, or if you convert that into percentage, 82.75%.